All right. I'm making this video to basically revise pointers. So I'll go through the basics of pointers so that the concept becomes clearer, and yeah, that's the point. So let's revisit pointers. Now we have to understand first that variables are stored in memory. Okay, so I'm showing you this program over here. So this is a C program, and here we have I equals to 2001, and we are printing the value of I, and then we are also printing the address of I. So how do we know it's the address of I? Well, it's ampersand I. So ampersand before the name of a variable suggests that it is a address. Okay, so let me give you an example of that, how it is laid out. So I would like to write on it. Okay, so now I can write. Good. So memory is laid out like this. So conceptually you can think of that it is contiguous memory locations are there, and we had used a variable called I, right? So and the value of I was let's say 1001. So this would be the value. So when we write int I equals to 1001, the variable I and its value 1001 is stored here. So every memory location has an address. Like we live in different houses, and houses have addresses and buildings have addresses, right? So in order to refer to them later, we have addresses for variables. So let's say this is address 2000. So we say that I is stored in location 2000. So location or address is the same thing. Address. Okay. All right. So when we do ampersand I, we get the address of the variable, right? So that's the idea. Now let's go back to the slide. Now let's go to pointers. So let's look how pointers are defined. So you see int star p. So you can read it as int pointer p, right? So star makes it unique. What does it mean? Well, it means that p is a variable that points to an integer memory because it's int pointer p. So now let's use the pointer p, right? So let's say there is a variable I equals to 20, and then we set p equals to ampersand I. That means p will store the address of I. All right. So now pointer p or star p means the value stored at the location pointed to by p. So if you print star p or pointer p, it will produce 20. Okay, so let's look how does that look like in memory. So we had int pointer p and then int I, and this is, let's consider this as a different I, and I equals to 10, and we say p equals to ampersand I, right? So it will look like this. So let's say we have variable I here, and it contains a value 10, and let's say this address is 2008, right? So ampersand I would mean 2008, So p, this int pointer p again will be a variable, right? And since it stores address, it will have 2008. Okay, so p contains address of I, and that is evident, right? P contains address of I. So when we say, let's say print star p, then star p would mean what is the value at address 2008. So doing star p would print 10, because what is stored in address 2008, right? 10 is stored there, so this would print 10. So star p should be read as a value at location contained in p. So value at the location contained in p. So what is contained in 2008, that's what it'll print, right? So it'll print 10. So let's do a practice problem now. So let's say I have variable int pointer x, and I have a value, integer value val equals to 99, and I do x equals to 9 and x equals to ampersand val, and then I do print pointer x. So can you draw a diagram when this code, these 4 lines will get executed? Can you draw the memory diagram, right? How does these variables are stored in memory? So yeah, pause it and then try to make a diagram like the one that I made it here. All right, so let's suppose you have done this thought experiment and tried this out. Yeah, I recommend you try before looking at the answer, which I'm going to present now. So again, just following the previous example, the memory diagram looks like this. So you have a integer variable called val, and that stores 99, and then let's say it is in address 1000, let's say 24, so it's 10,024. And then again we have a variable called x, and it is a pointer variable, right? So the unique thing about pointers are that they contain address. That's how they can point to, right? If you know an address, it's in other words, you can say, you can refer to that address and you go to that location. So pointers are unique and different from normal variables, in the sense that normal variables would store values and pointer variables will store addresses. So when I say x equals to ampersand val, then x is supposed to store 1024, right? And it itself is stored in some other memory location. Let's call it 1048. Okay, so when you do pointer x, then it's dereferencing the address. So dereferencing is the term that is used when you do star x pointer x. So here we are interested in what's the value stored in the address pointed to by x. So what is there in 1024? So it goes to that address and picks up this value. So this would produce 99. All right. So that's what happens in this case. Now let's go back to the slides. So for this pointer arithmetic example, the slide, here let's go through it. So there is an array, and the array contains 1 2 3 4, and pointer x is is equals to ARR. So name of the array. So with respect to array, you have to remember that name of the array acts as the address. So array has many different elements, so it will contain the address of the first location in memory. So ARR0 would be the first first element of the array. So that's the address that it will store. And when you do x plus plus, because it's an integer pointer, doing plus plus goes to the next element. So ARR square bracket 1, right? So let's look at this also. Let me create a new. Okay, so ARR equals to 1 2 3 4. So you can think of this as stored in memory. So that would be 1, and then 2, and then 3, and 4. And ARR basically points to the first element, right? And this would be ARR. This would be the address of ARR0. This would be address of ARR1. ARR2. So arrays are consecutively located. And if you think of the address, then it could be 1000. Integer takes 4 bytes, so 1004, then 1008, 1012, so on. So when you have, int pointer x equals to ARR, then you can think of this as there is a variable, name is x, and it contains the address. So it will contain 1000, because name of the array means is equal to address of ARR0. So both are same. Okay. All right. So when you do x plus plus, x is pointing to 1000. So when you do x plus plus, then the value changes. So it's no longer 1004. Now it is 1008. 1000. Oh no. So initially it was pointing to 1000. Now it will point to 1004. If you again do x plus plus, then there will be a change. It will get again incremented to point to the next location. Okay, 1008. Now when you do print, like printf pointer x, then says go to the location pointed to by 1008, and that is this, and then print 3. So 3 will get printed from here. Okay, so that's how pointers work. Since it's an integer pointer, doing plus plus moves it to the next element. That is moved by 4 integers, 4 bytes, because an integer takes 4 bytes. All right. So using that, this problem can be solved. Now the last thing that we will see here is, let's see. Yeah, we can see this program, swap program. So swap takes 3 and 5 as input, and then swap uses pointers to basically interchange A B. So A becomes B, B becomes A. Okay, so let's look at how this works. So A, B, X and Y. Yeah, just remember this program. Okay, and we can come back to it. So we have int a and b, let's say equals to 3, b equals to 5. If you have to make a memory diagram, it will look like this. So variable a, variable b, if this is 3, this is 5. Let's say this is at location 1002, this is at location 1006. So these are the addresses. These are the variables, variable names. And then you had a function void swap int pointer x and then int pointer y, and it has some logic. So x will have an address, let's say 1020, and then y will have an address, let's say 1024, and let's call this function swap and pass address of a and address of b. Okay, so when we do that from main, let's say this is the main function. When we pass a and b, these get stored, right? So the address of a gets stored in x, and that's why the reason we are using pointers will now become very clear, because pointers store addresses, and when swap is called, you're passing addresses, right? So x will contain the address of a, which is 1002, and y will contain address of b, which is 1006. Okay, now in the program we had int temp equals to pointer x, so we need one more variable called temp. Let me draw this here, temp, and temp equals to pointer x. So pointer x means go to the location 1002 and see what's the value. So that's 3, so temp will contain 3. Then this next line is pointer x equals to pointer y. Now when we do that, that means x, the value of 1002, go to location 1002, this one, and then that changes with value at location 1006, right? This one. So this would get overwritten and will become 5. Okay, so let's do that. This would become 5. And then last step is pointer y equals to temp. So pointer y means go to again the address 1006 and then put temp there, which is 3. So this, we have to now make that 3. So we write whatever temp is. So now we see that the value of a and b have been interchanged. Right, so 3 and 5, but now it's 5 and 3. So when the function swap returns, and if you print it here, you'll get the updated values 5 and 3. So the swap is successful now. Now if we don't use pointers in swap method or function, then the method will not work. So let's look at that. So instead of this line, if we had swap uh, A and B. So instead of passing the address, we are just passing the value of A and B. And let's say swap was defined like this: int x, int y. If the definitions were like this, then what will happen, right? Let's look at that. So A and B have a value 3 and 5. So we are doing it, from the beginning to see, if you don't use pointers, then what happens. Again, now you have x and y. So 3, the value of A is copied to x, value of B is copied to y. So x becomes 3, y becomes 5. And this logic of swapping will make it 5 and make it 3. So you see that the change has happened, but A and B, which were the original variables, input variables, which were passed to swap function, have not been changed. So if you print AB in the main function itself after swap, then you'll see that the values are 3 and 5. They have not been changed. On the other hand, using pointers here, as I showed here, the change happened. So that's why we use pointers if we need to make changes to parameters inside a function. Then pointers is the way to go. Okay. All right, so let's stop here.